Hi everyone. Today we're starting our unit on geometry, which is Module 5, Lesson 9. And we're going to look at examples of functions from geometry. So basically, how can we incorporate our algebraic skills into solving geometric problems? Our objectives for today are that students will write a function for the area or volume of a given figure. And we can interchange that word function with the word equation depending on your familiarity, right? Functions and equations are fairly similar. Our second objective says students will use given information about a figure to find its area, volume, or a side length. So basically what we're doing is finding missing pieces of shapes or three-dimensional figures. So the first example I want to look at is something that's a little complex. We all know that the area of a quadrilateral is length times width. But what if I had a shape that was sort of like a picture frame? So right now I'm drawing an 8 by 8 square with a 6 by 6 square centered in the middle. And I'm going to label some of those measurements. And let's assume that we're talking about units of 1 inch. So if we need to find the area of the picture frame, let's start with the blue square, or the outside of that particular picture frame. So the blue square has a side length of 6 plus those 1 inch picture frame borders, which gives me a side length of 8. 8 times 8 is 64. That would be the area of that large blue square. Where the green square has a side length of 6, 6 times 6 is 36. By subtracting the small square from the large square, I get the remaining area of the picture frame, which is 28 inches squared. It seems fairly straightforward to use this method to find that area of the frame, but what we're trying to get at is that you can combine areas in a process called composite areas to solve more complex problems as opposed to just what's the area of the square. So to generalize this scenario, we always subtract the smaller square from the larger square to get the area of the picture frame. So I'm going to jot myself another little kind of generic picture frame here. And if I use variables to label my side lengths as opposed to numbers, I could see how I could generalize this. If the small square has a side length of x, and I know the width of the picture frame is y, then the large square has an area of x plus y, or x plus 2y, times itself. The small square will have an area of x times x, or x squared. And subtracting the small square from the large square is still going to give me the area of the frame. So we can follow this model in different scenarios and still get an accurate solution. We can also use functions to solve volume problems. So remember, volume is three-dimensional space. It's kind of like measuring the water in a fish tank. So I drew myself a rectangular prism there. It's 12 by 3 by 3. And my volume formula is volume equals length times width times height. So I substitute the values that I know, 12 times 3 times 3. I get 36 times 3, which is 108 inches cubed. See how we're using our algebra skills to solve problems that are more visual problems, right? Using a smaller rectangular prism with a length of 8 and a height of 2, If I know my volume is 32, I can use those three pieces of information to solve for the width of my rectangular prism.